We often see electric poles set up at regular intervals alongside roads. To determine the length of the cable between two electric poles, you measure the space or the distance between them. Consider a situation where you need to determine the length of cable required to lay electric lines between multiple points in a locality. If you create a map of the locality and transpose it onto a graph, you can derive the formula to calculate the distance between any two points in the locality. Welcome to the lesson, Distance Formula. In this lesson, you will learn how to apply the distance formula in coordinate geometry. At the end of this lesson, you will be able to apply the formula for calculating the distance between two points. Examine the corollaries of the distance formula. Consider the locality shown in the map. A power station is positioned centrally in the locality. The power station is laying cables to supply power to a new school and a stadium. The cable lines will go to the school via the stadium. The electricity department charges customers on the basis of the length of the cable required at the rate of 10,000 rupees per kilometer. Determine the expenses incurred by the school authorities for laying the cable. To determine the length of the cable required, we need to find the distance between the power station and the stadium, and then the distance between the stadium and the school. If the map is transposed onto a graph, you can derive the formula to find these distances through coordinates of various points. We can take the power station as the origin in the graph, as it is centrally located. First, let us derive a generic formula to obtain the distance between any two points with the help of their coordinates. In the graphical representation of the distance formula on the screen, let point P, x1, y1 represent the stadium on the graph, and point Q, x2, y2 represent the school. To find the distance between points P and Q, we draw a perpendicular line from point P to the x-axis. This line intersects the x-axis at point R. We draw another perpendicular line from point Q to the x-axis. This line intersects the x-axis at point S. The x-coordinate of P is x1. This denotes that the distance from origin O to point R on the x-axis is x1. Similarly, the x-coordinate of Q is x2. This denotes that the distance from origin O to point S on the x-axis is x2. Now, the length of RS can be determined. RS equals OS minus OR, which is x2 minus x1. Next, we draw a perpendicular line from point P to line QS intersecting at point T. If you notice, the distance from point P to R is y1, because the y-coordinate of P is y1, which is equal to ST. Similarly, distance from Q to S is y2. Therefore, distance TQ equals SQ minus ST equals y2 minus y1. Distance RS is equal to distance PT, which is equal to x2 minus x1. As you can see, PTQ is a right-angled triangle. Pythagoras' theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Therefore, in triangle PTQ, the square of PQ is equal to the sum of the squares of PT and TQ. On substituting the values of PT and TQ, you get PQ equals square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. Therefore, the distance between any two given points on a graph can be calculated using the formula square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. Let us refer to the graphical map that shows the power station, the school, and the stadium. Since the cable has already been laid from the power station to the stadium, the power station will lay the cable from the stadium to the school. To calculate the length of the cable, we will calculate the distance between the stadium and the school. In the graph, the coordinate of the stadium is 3, 4, and the coordinate of the school is 6, 8. According to the given data, the cable costs 10,000 rupees per kilometer. Stadium P is at 3, 4 and school Q is at 6, 8. The distance between the stadium and the school is represented by line segment PQ. The formula for calculating the distance is square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. Substituting x1, y1 equals 3, 4 and x2, y2 equals 6, 8 and simplifying, you get distance PQ as 5 kilometers. Therefore, the total expenditure incurred by the school authorities for the cable will be 50,000 rupees. Using the same method, we can find the distance between any two points in the given locality. For instance, consider the length of the cable laid from the power station to an auditorium as shown on the map. On the graph, the power station is at the origin 0, 0 and the auditorium at -9, -12. The formula for calculating the distance is square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. When you substitute x1, y1 equals 0, 0 and x2, y2 equals -9, -12 in the formula and simplify, you get the distance of OA as 15 kilometers. Thus, the distance between the power station and the auditorium is 15 kilometers. Thus, you can find the distance of any two points using the distance formula when the coordinates are given. The distance formula can be further simplified for specific scenarios. For instance, to find the distance of a point from the origin, that is, the center of your graph, you can use the following formula, square root of x squared plus y squared. To verify this, let us consider again the problem where we calculated the length of the cable laid from the power station to the auditorium. On the graph, the power station is placed at the origin 0, 0 and the auditorium at -9, -12. On applying the formula square root of x squared plus y squared, you get length OA is equal to 15 kilometers. As you can see, the values obtained using both the formulas are equal. So far, you have been calculating distances between two points. However, there may be cases where we have three collinear points on a graph. According to a corollary of the distance formula, where 3 points on a graph are given, and the sum of the distances of 2 points from a third point is equal to the distance between the first 2 points. The 3 points on the graph are collinear. For example, in the given figure, the 3 points A, B and C are collinear if the sum of the distances between A and B and C is equal to the distance between A and C. In other words, the 3 points A, B and C are collinear if AB plus BC equals AC. Consider the distances between the power station at origin O 0, 0, the stadium P 3, 4 and the school Q 6, 8. Apply the distance formula for the points given. You can calculate OP, PQ and OQ. Thus, OP is equal to 5 kilometers, PQ is equal to 5 kilometers, and OQ is equal to 10 kilometers. As you can see, the sum of OP and PQ is equal to OQ, and the power station, the stadium and the school all lie on the same line. That is, they are collinear.